Hello ipXers, again we are here at Embedded World 2024 where we're going to talk all about data. Well, actually we're not going to talk about data, we're going to talk about losing data. In fact, we're not going to talk about losing data, we're going to make sure that you don't lose your data. So we're going to introduce you to
Marko.
He's much better at saying that than I am, from a company called
Tuxera.
Excellent. From
Finland.
Anybody would think that we practiced this. We didn't, because we all know I'm incompetent. Right, tell us about what you do with data and how you ensure that those design engineers out there who are totally paranoid about losing their data don't.
So let's say that you are designing a car or you are building a car.
Yep.
And you have put some cameras into the car, or you have some other DVR applications in the car, camcorders and the likes.
Yep.
And then you have a challenge.
I know you have a story, but we could take this as being any industrial computer vision as well, couldn't we? Potentially. Yeah. So it's anywhere where you've got data.
Anywhere where you get data, you are storing it via a camera to an SD card.
Yes, that's right. That's fine. Just to clarify. Okay, keep going with your story.
All right. So you want to make sure that if there is any type of power loss, let's say you have a crash, which is unfortunate, but it can happen. Someone damages your car.
Yep.
What will happen is that there is many times a power loss. And then you have a problem. Did you actually store all the frames? Or did they get lost? Did the media get damaged? Did it get corrupted? So can you actually see from the feeds what actually happened? Can you recover it? So what we have done is a solution called Persistence Manager. And what it actually allows you to do is that allows you to save and have a predictable time interval that it takes to save all the information from the video, from the DVR to the actual storage. And the typical way that you actually solve the problem is that you have to keep the power on for a long period of time. And if you look at the standard solution, it's up to 30 seconds.
Right.
And if you save it up to 30 seconds, it has a cost because you have to have a solution to keep the power on for that period of time. And that is typically done by implementing, for instance, a supercapacitor.
Yeah.
The issue with the supercapacitor is that it has a pretty high cost, up to $4 per supercapacitor.
Right.
With our solution, because we can guarantee that there's never an interval that is more than 2 seconds, you can use a much cheaper capacitor.
Right. So you're taking away from bill of material immediately with your solution?
Absolutely. Up to $3 per device.
That's a lot of money.
That is a lot of money. And on top of that, we can guarantee that if there's any type of power loss, there's never a corruption.
Right. So if I'm a design engineer now and I'm working on, some kind of sensor, some kind of information, you use the idea of a camera in a car, and I need to protect that data. At the moment, whatever happens, the only solution I've got is a $4 part supercapacitor that's going to keep the power going for up to 30 seconds. And what you're saying is you don't need that. You can just use our software, which will be doing it how many every
2 seconds.
Every 2 seconds. Right.
Yeah. So you can have much cheaper capacitor. The normal capacitor will do just fine, and you will save a lot of money.
Right. And how many in a typical car is it only at one point that they use a supercapacitor, or multiple supercapacitors around the car?
It depends on the design, but it can be one, it can be multiple.
It can be multiple, so you're not just talking about $4, you might be talking about multiple dollars.
Yes, indeed.
Right.
Depends on how many cameras you have.
Right.
Many people use one to, look ahead, one look behind.
Yeah, and around the car as well.
Yeah.
Okay, fine. So how do you do that?
So how we do that is a secret, of course. It's the IPR that we have. So unfortunately, I can't tell you exactly how we do it.
I'm glad we're doing this video. Yes. It's a secret.
That's why we have a product for it. So it unfortunately costs some money that we take away your problem. But how it actually works is that, of course, we have...
I didn't mean you telling me how it actually works. I just meant how would a design engineer go and have a look at it?
How to have a look at it is just to let us know.
Are you going to show us a demo?
Yeah, the demo is actually running here. So in here you can see the run-of-the-mill open source implementation. And in here you can see our persistence manager. So you can see that the latencies are up to 82% less than in the open source. But this is not the most important thing, because this just shows you the average latency. But what is actually important is that if you design a car, you need to know what is the maximum amount of time it takes to flush all the data.
Yeah.
And with the open source standard run-of-the-mill type of a solution, it's up to 30 seconds.
Right.
And we can guarantee that it's never more than 2 seconds.
Right. So this open source you can get from anywhere, and you just implement it yourself, using maybe a third-party vendor to do that for you. And what you're saying is you just use your software, and you guarantee that it will always keep data for up to 2 seconds.
Yes.
Right. So what do they actually buy from you at that point? Although it's a secret, what do they buy from you?
They buy a product, so it's a product that they would integrate to their system, the DVR software.
Right.
And that's it.
That's it.
That is it.
Okay. Now, so if I'm a design engineer and I don't believe a word of what you've just said, because it sounds a little bit unbelievable, because of the amount of difference that you're making, how do I evaluate that? How do I come to you and say, right, I need to prove that I need to crash test dummy this, for want of a better phrase.
Yeah.
How do I do that?
Well, that's very, very simple. You run an evaluation. So you get the software from us, you integrate it as part of your stack, and then you pull out the power plug, and then you see what happens. Then you see that there's no corruption, and we actually guarantee that it's never more than 2 seconds. So that's the way you evaluate.
You're actually able to guarantee that?
Yes.
Right. So, in summary, if I'm a car manufacturer, I need to keep data. Currently, I'd have to spend a lot of money on a supercapacitor that might cost up to $4. If there's an accident, I need to make sure that my images aren't corrupted, which means I need to be saving them every 2 seconds. Yes?
Yes.
Yes. And what you're saying is, we can do all that in software, save you that component, and we guarantee it.
Yes, indeed. Absolutely.
Although it's a secret as to how they do it, but that's okay. Thank you very much. That's a really good introduction.
Hey, yo, where my engineers at?